Hi everyone! Today we're going to study compound interest. First, let us recall the simple interest is charged when the lending period is short and often less than a year. Now let us define compound interest. When the money is loaned or borrowed for a longer time period, the interest is paid or charged not only on the principal but also on the past interest. And we say the interest is compounded. And that is why we call it compound interest. Banks often compound interest more than one time a year. Consider a bank that pays 8% interest but compounds it 4 times a year or quarterly. This means that every quarter the bank will pay an interest equal to 1/4 of 8% or 2%. Therefore, if we invest a lump sum amount of principal P at an interest rate R, compounded n times a year, then after T years, the final amount, denoted by capital A, is given by this formula, that A equals P times the quantity 1 plus the fraction R over N, and this quantity is raised to a power that is a product of N times T. Here is a note that there are words that denote n number of times interest is compounded. First is yearly or annually, and that is n equals 1. For half yearly or semi-annually, the n equals 2. Quarterly means n equals 4. Monthly means n equals 12. And the last is daily, where n equals 365. Let us see this example 1. If $3,500 is invested at 9% compounded monthly, what will the future value be in 4 years? First, let us write our formula, and it's now written here. And then, let us collect the given values of the problem. First is the principal P, and that is the $3,500, followed by the rate, denoted by R, and that is 9%. And this percent we will convert into decimal. First, we will put this number 9 over 100. We drop the percent sign, of course. And then the quotient 9 over 100 is 0.09. Then, the number of times the interest is compounded, it's written here monthly. So we will write n equals 12. Next is the time, denoted by T, and that is 4 years. So in this problem, we want to get the future value using this formula. Let us copy again this formula here, and then let us do the substitution. A equals, the P is now changed into 3,500. 1 is a constant, we will copy that. Then plus the fraction R over N. The R now becomes 0.09 over the N, and we change N into 12. The exponent, and that is a product, N times T. Our N is 12 and T is 4. Let us simplify further. First, let us get the product of 12 and 4, and we will get 48. Next is, let us simplify this fraction, 0.09 over 12, and we will get this 0.0075. And then we will add 1 plus this decimal, and that is now 1.0075. Using our calculator, let us simplify this expression, this 1.0075 raised to power 48, and the value is 1.431405. We will multiply this decimal into 3,500, and our answer is 5,009.92. This is the A. This is the future value in 4 years. We will not forget our dollar sign, that is our unit of the money, and this is now our final answer. Let us see example 2. How much should be invested in an account paying 9% compounded daily for it to accumulate to $5,000 in 5 years? Now, let us first write the given, starting with the rate, and it says 9%. Let us convert this 9% into decimal. Of course, that is 9 over 100, and this value equals 0.09. Next is the number of times the interest is compounded, and it is written here daily. It means the value of N is 365. Next is the future value, and that is the $5,000. And then the time denoted by T, that is 5 years. In this problem, we need to get the principal, or P. We will use the same formula, and then let us do now the substitution. The A becomes 5,000 equals P, that is what we want, we will copy it here. 1 is a constant, we will copy that, plus R over N. Our R is the 0.09 over N, that is 365. And this value is raised to an exponent, and that is the product NT. N is 365 while T is 5. First, let us simplify by taking the product of the exponent, 365 times 5. We will get 1,825. And then, let us simplify this fraction, 0.09 over 365, and the value is 0.00024 1.657. Let us add this decimal with this constant 1. We will get 1.0002467. And this decimal must be raised to that exponent 1825. And the simplified value is 1.56821. We want to get letter P, so let us divide this equation by the coefficient of P, and that is this 1.56821. Now, the left side 5000 will be divided by 1.56821, and it will be like this. And this is equal to the right side. That decimal will be cancelled out. Only P comes down. The quotient of this value is now equal to 3188.35. This is our P. This is the principal. Let us put our $sign, and this is our final answer. Hi everyone. Today we're going to study effective interest rate. Let us define effective interest rate. The effective interest rate, effective annual interest rate, annual equivalent rate, or simply effective rate, is the interest rate on a loan or financial product restated from the nominal interest rate and expressed as the equivalent interest rate if compound interest was payable annually in arrears. For comparison purposes, the government requires the bank to state their interest rate in terms of effective yield or effective interest rate. The formula for effective interest rate is given here. Capital E equals the binomial 1 plus the fraction r over n, and this binomial is raised to a power n, and this whole expression is subtracted by 1, where this capital E is the effective rate, this r is the rate, and the n is the number of times interest is compounded in a year. Take note, the n is found as the denominator of the fraction, also the exponent of the expression here. Let us see this example 1. If a bank pays 7.2% interest compounded monthly, what is the effective interest rate? Let us write the formula here, and let us begin to write the given of the problem, starting with the rate denoted by R, and that is the 7.2%. Next is, we're going to convert this percent into decimal. So we will have the 7.2 over 100, and the quotient will give 0.072. Next is the number of times the interest is compounded. it is written here monthly, so we will write n equals 12. Now we are ready to use our formula. Let us do the proper substitution on this side. So we will have capital E equals, we will copy the constant 1 plus the fraction r over n. So r becomes 0.072 over n, that is 12. And the power n in here becomes 12 also, and minus the constant 1. On the next line, let us simplify this fraction 0.072 over 12. Using our calculator, we will get 0.006. And then let us get the sum of this 1 plus 0.006, and that is 1.006. This decimal is raised to a power 12, and the value will be 1.0744. And then let us subtract this by the constant 1. Our effective interest rate is 0.0744. Let us convert this decimal into percent. We will multiply this by 100%. So we will get this value 7.44%. This is our final answer. There are notes here that says interest can be compounded yearly, semi-annually, quarterly, monthly, daily, hourly, minutely, and even every second. When interest is compounded infinitely many times, we say that the interest is compounded continuously. Let us see this example too. If an amount is invested at 7% compounded continuously, what is the effective interest rate? In this type of problem, we are going to use a special formula, and that is capital E equals small e raised to r minus 1, where this capital E is the effective rate. The small e here is a special constant in math that is equal to 2.71828, and so on. We can get this value from our calculator directly. And the r is the rate that is given in the problem. In this case, our rate is 7%. Let us convert this 7% into decimal. We will divide the 7 by 100. Of course, we drop the percent sign, and the quotient is 0.07. Now, let us solve our effective interest rate. We copy again the formula here, then let us do the substitution. Capital E equals the small e raised to r, and the r is now 0.07, and this value is minus 1. We can use the calculator to get directly this e raised to 0.07, and the value is 1.0725. We will subtract this decimal with that constant 1, and the answer is 0.0725. Let us convert this into percent. We will multiply by 100%, and the value will be 7.25%. This is our effective interest rate. Remember, we are using this special formula because the principal, which is unknown, is compounded continuously. And the 7.25% is our final answer. Hi everyone. Today we're going to study interest compounded continuously. First, let us recall interest can be compounded yearly, semi-annually, quarterly, monthly, daily, hourly, minutely, and even every second. When interest is compounded infinitely many times, we say that the interest is compounded continuously. For interest compounded continuously, we say that if we invest a principal P at an interest rate R per year, compounded continuously, after T years, the final amount A will be given by this formula. Capital A equals capital P times the constant E, and this is raised to a power which is a product of R times T. Take note that this E is a special constant that is equivalent to 2.71828 and so on. We can get this number directly from the calculator. Let us see example 1. If $3,500 is invested at 9% compounded continuously, what will the future value be in 4 years? First, let us write our formula here, and then let us list the given of the problem. Beginning with the principal P, and that is the 3,500, followed by the rate denoted by small r, and that is the 9%. We convert this 9% into decimal. First, let us drop the percent sign and divide the number 9 by 100. And the quotient will give us 0.09. Next is the time denoted by T, and that is 4 years. Now we are ready to use our formula. Let us write it again in here. Then let us do the substitution. So we have this capital A equals, the P is now changed into 3,500 times the constant E that is raised to the product RT. The R is now changed into 0.09 times the time, which is 4. To simplify further, let us begin by taking the product of this exponent. 0.09 times 4 will give us 0.36. Let us use our calculator to get this value, and the answer will be 1.43333. This decimal we will multiply to 3,500 and the product will be 5,016.65. This is our A. This is the future value. Of course, we will attach our dollar sign, and this is our final answer. Let us see this example 2. If an amount is invested at 7%, estimate how long it will take to double. For our solution, let us bear in mind that we are looking for the time. Since we are estimating the answer, we really do not care how often the interest is compounded. Let us say the interest is compounded continuously. Then the formula A equals capital P times the constant e raised to RT becomes like this. To double the amount, it means to double that principal, so the A is now changed into 2P equals the same right side. We can see here that both sides have this letter P. So we can divide this equation by the P to simplify. So the next equation will be 2 equals the constant e raised to the exponent RT. In our given here is the rate, which is 7%. And we know that the 7% is equal to 0.07. We can now substitute this decimal for R in our equation. Let us continue on this side. So we can write now 2 equals the constant e raised to the product 0.07 times t. In this case, only the t is the variable. To solve for t, what we're going to do is to take the natural logarithm of both sides. So we will write ln of 2 equals the ln of this e raised to that product 0.07 times t. I hope you still remember that ln of e raised to x can be simplified into x. So we can simplify this equation further by writing ln of 2 equals this exponent now, the 0.07 times t. We can get the value of ln2 in our calculator. We want now to isolate t. We will divide the equation by the coefficient of t, and that is the 0.07. So on the left side, we will see ln of 2 all over 0.07 equals the right side. This constant 0.07 is now cancelled out. Only t comes down. Using our calculator, the value of t can be derived, and it is equal to 9.902. We can round off our answer and we can write 10. And the time here is in terms of years. It means to say, for an amount that is invested at 7%, it will take about 10 years to make it double. This is our final answer. I hope you learned something from this video. See you again next time. Hi, math enthusiasts! I would like to invite you to join us and be a member of e-DEOlogy community. If you become a member, you will help e-DEOlogy YouTube channel to make more math videos and to ease logistics expenses. As a member, here are your perks. All members will receive this beautiful and customized e-DEOlogy Fun Badge. There are 3 levels of membership. The first level is Bronze. Bronze members enjoy 100% of videos, plus Bronze Certified Member Badge that look exactly like this. The second level is Silver. Silver members enjoy 100% of videos, plus you will receive the Silver Certified Member Badge, and it is here. As a Silver member, you are considered to be a sponsor of 3 members-only videos, plus you are a sponsor of 1 public video. This public video means these are merged videos of 3 to 7 math topics. As a sponsor, acknowledgement is given on the latter part of the video, that is, your name or your channel is shown as one of the sponsors. The third level and the highest is Gold. Gold members enjoy 100% of videos. Plus you will receive this Gold Certified Member Badge, and it is here. As a Gold member, you are considered to be a major sponsor of 30 members-only videos, plus major sponsor of 10 public videos. As a major sponsor, acknowledgement is given on the early part of the video, that is, your name or your channel is shown as one of major sponsors. See you all in e-DEOlogy community and get this beautiful e-DEOlogy Fun Badge and be a member according to your interest as a Bronze member, a Silver member, or a Gold member. We love to see you in e-DEOlogy community.